Hello, friend, and welcome to the Sleepy Meteorologist. Tonight, we'll explore why some storms feel stronger after sunset. When the day's hustle fades and the world grows still, the sky doesn't always rest. Sometimes, that's when it begins to stir. As you settle in, the evening air deepens. Clouds gather softly in the distance. A hush falls over the land. But above, something changes. A delicate shift, a quiet tension, and then, perhaps, a rumble. Maybe your day has been long, or maybe your mind just needs a gentle place to drift. Wherever you are, however you're feeling, you've made it here. How's the sky looking tonight, just outside your window? If you enjoy these calming meteorology journeys, you're welcome to like or subscribe. Your presence helps other sleepy travelers find their way to this quiet corner of the sky. For now, there's no need to think or do. You can simply listen. You can simply rest. The science of storms will wait for you. And the clouds, well, they're in no hurry either. Let's begin. Good evening, and welcome back to the Sleepy Meteorologist. Tonight, we turn our gaze toward the horizon at dusk. A soft stillness settles over the land. But high above, the sky is far from still. In this gentle chapter, we'll explore a quiet question that has lingered through time. Why do some storms wait for nightfall? As sunlight fades and twilight deepens, the air seems to hush. The breeze grows slower, like a lullaby for the earth. Lights begin to flicker in windows. Stars prepare their entrance. And yet, for reasons subtle and unseen, some of nature's most powerful weather arrives when the rest of the world is winding down. Evening storms carry a certain mystique. They often bloom after sunset, when the landscape has cooled and the skies take on dusky hues of blue and violet. This isn't the loud, brash thunder of daytime convection. No. This is a slower, sleepier unfolding, a deeper stirring in the sky's hidden layers. During the day, the sun pours energy into the Earth's surface, warming the ground and the air above it. That warmth rises, fueling what meteorologists call convection, columns of upward-moving air that help build clouds, then storms. But when the sun sets, the surface cooling begins. And you might imagine that means storm energy should fade too. Sometimes it does, but sometimes it doesn't. Here lies the mystery. As the ground cools, it settles the lower layers of the atmosphere into stillness. Meanwhile, up above, the air may still be moving briskly, especially if a jet stream flows nearby. The resulting contrast between calm surface air and fast upper winds can create something special, a stable base and a storm-friendly sky above. In this arrangement, the atmosphere begins to favor more organized, long-lasting storms. Rather than quick daytime downpours, these are the graceful travelers, storms that drift through the night, guided by invisible rivers. Of wind aloft, storms that form in the evening also face less competition. Without dozens of small daytime cells fighting for space, a single well-developed storm can flourish. It becomes a quiet king of the night, glowing with lightning as it moves slowly across the land. There's something cinematic about it, something hushed, something that invites curiosity rather than alarm. Some of these nighttime storms are what meteorologists call elevated storms. They draw their energy not from the warm surface below, but from a layer of warmer, moister air higher up. A gentle inversion that allows the storm to glide above a stable world. These elevated layers, unseen but vital, hold the keys to understanding much of the nighttime storm puzzle. So, when you hear a distant rumble after dark, know that the sky is telling a different kind of story than it did during the day. One shaped not by heat and chaos, but by balance and subtlety. Tonight, as you settle in, you can rest in the knowledge that the skies above are moving in harmony with unseen forces, and all is unfolding exactly as it should. Let the sound of rain, if there is any, be your lullaby. Let the clouds whisper as they pass. And now, let's float deeper. Welcome back. And thank you for staying with the Sleepy Meteorologist. In this chapter, we continue our journey into the nighttime skies, focusing on what happens when the sun slips away and the earth begins to cool. The transition from day to night is a quiet one. You may not feel it immediately, but the atmosphere does. As shadows grow longer and sunlight fades, the balance of heat begins to shift, slowly, subtly, like a gentle turning of gears in the sky. During the day, sunlight warms the Earth's surface. That warmth radiates upward, heating the air closest to the ground. This is the layer we live in, breathe in, walk through, the troposphere. But as the sun disappears behind the horizon, that warmth begins to escape, rising softly back into space. The ground, no longer fueled by sunlight, starts to release the heat it gathered. It cools from the bottom up, but the air above, especially higher layers, cools even faster. This creates something called an inversion. It's a graceful flip of temperature layers, where cooler air hugs the ground and warmer air floats above. Though this sounds upside down, it's a natural part of the evening sky's routine, and with it comes a new kind of balance. Inversions act like gentle lids, calming surface winds and suppressing upward motion. You may notice the world quieting, the breeze softening, even the sounds of the evening carrying farther, as cooler air near the ground helps sound waves travel longer distances. But while the surface calms, the atmosphere above may still be holding on to energy. Moisture, warmth, and subtle winds can combine to support storm development, not near the surface, but within the elevated layers above the inversion. These higher layers may be buoyant and ready, quietly poised for motion. It's in this balance between the cooling ground and the stirring sky that nighttime weather becomes unique. Some storms are born in the late afternoon and continue into evening, gently drifting forward on the memory of daytime heat. Others form entirely after dark, springing to life in the elevated layers, where warm, moist air remains quietly buoyant above a calm earth. This balance isn't just beautiful, it's essential. The cooling of the atmosphere helps redistribute energy, reset wind patterns, and pave the way for tomorrow's weather. Think of it as the Earth's nightly exhale. And just as our bodies respond to nighttime cooling, slowing heart rates, softening breath, the Earth does too. This is a time of restoration, of recalibration, a return to equilibrium. So, as you listen now, perhaps tucked beneath your favorite blanket, let yourself mirror the sky. Let your breath slow with the cooling air. Let your thoughts settle, like mist on a meadow. The storms, if they come, are moving through this balance, shaped by layers you cannot see, guided by gentle temperature shifts, and nurtured by the quiet work of night. The atmosphere is always adjusting, always harmonizing, and tonight it's doing so softly. Let's drift onward. Welcome back, dear listener, as we continue drifting through the Sleepy Meteorologist. Tonight, we float into one of the quietest transformations the atmosphere performs. A change so gentle, you may only notice it as a slight chill on your skin. or the way the air feels calmer than it did just an hour ago. This chapter is about radiational cooling, the slow, graceful drop in temperature that happens after sunset, as the Earth releases heat into the sky above. During the day, the sun gives energy freely. It pours warmth into rooftops, fields, sidewalks, oceans, forests, into everything the light touches. But when night arrives, the flow reverses. The Earth becomes a storyteller, giving back what it has gathered. Heat rises from the surface as invisible infrared radiation. It doesn't rush, it doesn't roar, it simply lifts upward, quietly leaving the ground, slipping into the open sky like a soft exhale. This is radiational cooling, and it happens everywhere, though not equally. Some places cool faster than others. Dry desert landscapes, for example, can cool very quickly because there is little moisture to hold warmth. Grassy fields cool gently. Concrete cities hold heat longer, releasing it slowly through the night, like warm stones beside a campfire. But no matter where you are, the boundary layer, the lowest part of the atmosphere, responds. The boundary layer is the air closest to the surface. It's where we live, where fog forms, where breezes brush the skin. In daytime, this layer is often lively and mixed, stirred by sunlight and rising thermals. Warm air rises, cooler air sinks, and the atmosphere becomes a slow-moving dance. But after sunset, that dance begins to slow. As the ground cools, the air touching it cools too. Cooler air is heavier, so it settles downward, pooling near the surface like gentle water in a quiet basin. Meanwhile, the air above may remain warmer for a time. This creates stability, a calm layering that resists vertical motion. In meteorology, stability means the atmosphere is less willing to lift. It becomes sleepy, settled, and quiet. It's why nighttime often feels still, why smoke from a chimney might drift sideways instead of rising, why sounds travel farther in the cool air, why the world seems wrapped in hush. And yet, radiational cooling doesn't always bring only stillness. Sometimes it creates conditions that allow the atmosphere to shift into something different. Because while the surface becomes stable, changes in wind and moisture above can introduce destabilization in higher layers. It's a delicate balance. If warm, moist air flows in above the cooled surface, perhaps carried by a nighttime low-level jet, then the atmosphere can become unstable aloft, even while the ground remains calm. In this case, storms may not need surface heat to rise. They can feed from that elevated energy, building quietly in the darkness. It's almost like the Earth is sleeping, while the sky dreams. Radiational cooling also invites mist and fog. As temperatures drop toward the dew point, moisture condenses into tiny droplets. Sometimes fog forms as a thin veil over fields. Sometimes it settles in valleys, pooling like silver milk. Sometimes it drifts across roads in soft ribbons. And in those moments, the world feels suspended, half real, half dream. So, as you listen tonight, imagine the ground beneath you slowly releasing its warmth. Imagine the air becoming layered and smooth, like sheets of silk. Imagine the boundary layer settling into calm. While above it, the atmosphere continues its quiet work. Radiational cooling is not dramatic. It is not loud. It is simply the Earth, gently letting go. And now, with the temperature dropping softly and the night deepening, we drift onward. Welcome again to The Sleepy Meteorologist. In this chapter, we return briefly to the daylight hours, not to wake the mind, but to understand something tender and important: how the warmth of the day can linger into the night, stored like quiet fuel for storms that arrive after sunset. Because the atmosphere has a memory, even when the sun is gone, the effects of its heat can remain, held in the ground, held in the air, held in moisture and movement. Daytime warmth doesn't vanish instantly. Instead, it becomes part of a slow, unfolding story, one that sometimes ends with storms after dark. During the day, sunlight warms the surface, and that warmth spreads upward into the lower atmosphere. The air becomes buoyant. Thermals rise like invisible bubbles. Clouds begin to form, often as soft, fair-weather cumulus. White, drifting shapes that seem almost sleepy themselves. But as the day continues, the heat can build, especially on humid days, when moisture thickens the air and holds energy like a warm blanket. Meteorologists often describe this stored storm energy as instability. In simple terms, instability is the atmosphere's willingness to rise. It's the sense that warm air near the surface wants to lift upward, while cooler air above invites it. And as heat builds quietly through the afternoon, instability can increase, sometimes without obvious signs. The sky may still look peaceful, the breeze may still feel gentle, but the ingredients may be assembling. Warmth, moisture, lift, wind. The earth, meanwhile, stores heat like kindling. Fields absorb sunlight. Pavement gathers warmth. Water holds heat longer, slowly releasing it through evening. Even forests and hillsides keep a quiet record of the day's energy. And then, the sun sets. At first, everything seems to calm. The surface begins to cool, and the lower atmosphere becomes more stable, as we explored in the last chapter. But above that stable layer, the stored warmth can remain, especially if moisture is still present. This is where the nighttime storm mystery deepens. Sometimes, what's needed is only a spark. That spark might be a cold front arriving late in the day, or a subtle boundary between air masses, or a wave of low pressure moving quietly overhead, or winds shifting direction just enough to encourage lift. When that spark arrives, the stored energy can release. Not violently, at least not in our telling tonight, but purposefully, like a slow ignition. The atmosphere begins to rise again, not from the surface perhaps, but from a layer above it. The warm, moist air lifts, cools, condenses, and forms clouds that thicken into towering shapes. And suddenly, the evening sky is no longer only twilight. It becomes theatre. Clouds stack in shadowy layers, their tops brushing moonlight. Lightning may flicker behind them, soft and distant, like a silent lantern. Thunder may arrive as a low rolling sound, more like a deep drum than a sharp crack. Nighttime storms often feel different because they are often more organized. With fewer small daytime storms competing for energy, a single storm system can gather strength. And with winds stronger aloft, storms can travel smoothly through the night, guided by the invisible flow above the stable surface layer. In some cases, the low-level jet strengthens after sunset, transporting warm, moist air into storm regions. This can feed storms even when the ground below has cooled. It's like delivering fresh fuel to a fire that doesn't need sunlight anymore. So, yes, daytime heat builds quietly through the day, stored like kindling. And when the right spark arrives after sunset, this stored energy can ignite a stronger nighttime storm. But remember, this is not a story of fear. It is a story of balance. The atmosphere releasing what it has held, the earth sharing back its warmth, the sky moving through its rhythms like breathing. And as you rest, safe and still, you can let this knowledge soothe you. Storms are not random. They are not cruel. They are simply nature's way of moving energy, slowly, patiently, from one place to another. Now, with the day's warmth fading into memory, we continue drifting forward. Welcome back to this quiet moment with the sleepy meteorologist. Tonight, we drift into a softly layered chapter about the gentle trap that sometimes forms in the sky as the day ends and the night takes hold. This is the story of the evening inversion, a graceful flip in the atmosphere, where warmer air rests above cooler air near the ground. It may sound simple, but this subtle shift can create a kind of invisible lid in the sky, one that holds moisture, wind, and energy close to the surface. Let's ease into it. During the day, the sun warms the earth from above. The ground absorbs that warmth and sends it back upward, heating the air near the surface. This warm air rises naturally, mixing the lower atmosphere like a slow-moving current. But after sunset, the surface begins to cool. The warmth fades from the ground, and the air that touches it cools as well. Because cool air is heavier, it sinks and settles into valleys, hollows, and low places. Above it, the air may remain warmer for a while, especially on calm, clear nights. This gentle layering of warm over cool is what meteorologists call a temperature inversion. And while the term might sound technical, it simply means the atmosphere has turned itself upside down for a time. Normally, air cools as you go higher, but in an inversion, the opposite is briefly true. A warmer layer floats quietly above the cooler air near the ground, forming a kind of invisible ceiling. This cap holds everything beneath it in place: moisture, air currents, and sometimes turbulence. Picture it like a glass lid over a simmering pot. Beneath the inversion, moisture released by plants, soil, or earlier rainfall can become trapped. Fog may begin to form. Mist may gather in open fields or forest edges. The world below feels damp, quiet, and close to the ground. This trapped moisture can also help storms grow if the inversion weakens or lifts. Sometimes during the evening, the atmosphere begins to release that built-up energy, and a storm quietly stirs into motion. The inversion can also trap low-level turbulence, tiny eddies of wind, swirls of motion close to the earth. These disturbances aren't always strong, but they can help feed the base of developing clouds. If winds are turning with height, changing direction gently as they rise, it can even lay the foundation for storm rotation later on. But most of the time, the inversion creates a feeling of calm. Winds below may slow or even stop. Smoke may hang low. The scent of night-blooming flowers lingers longer, and sound carries farther, gliding along the cool, stable air near the surface. In aviation, pilots are familiar with this inversion. It can cause a bumpy ride near the surface as winds become trapped and compressed beneath the cap. But above that lid, the air may be smoother, more cooperative, flowing quietly across miles. This atmospheric setup also means that storms forming above the inversion may behave differently. They aren't rooted at the surface. They're elevated, feeding on energy higher up, gliding above the calm earth like drifting ships in the upper sea. And if that inversion breaks, if the cap weakens, then all the moisture and warmth below can rise at once. The lid lifts and the pot begins to boil. But tonight, we're not here for boiling or bubbling. We're here to rest in the stillness of layers, to understand that the sky holds secrets in its structure, and that even when things feel quiet, there may be quiet power waiting just above our heads. So, as you lie in stillness, You might imagine that warm, invisible layer, resting gently above cooler air, tucking the world beneath it like a soft blanket. The evening inversion is not a danger. It is a pause, a holding place, a soft trap for turbulence and a keeper of calm. And now, wrapped in its quiet, we move forward. Welcome, gentle traveller, to Chapter 6 of The Sleepy Meteorologist. Tonight, we explore a quieter kind of motion, a shift that happens not with thunder or flash, but with grace. This is the story of wind shear, and how, after dark, it becomes more pronounced. It's the art of the sky's winds, moving in different directions, at different heights, turning invisible currents into layers of motion that shape the way storms behave. As day gives way to night, the surface begins to cool. Winds near the ground often slow down, resting like the world itself. Trees become still, flags hang quietly, grasses barely stir, but far above, the wind still flows. The atmosphere doesn't sleep the way we do. Even while the earth rests, the jet stream, those fast-moving rivers of air miles above the ground, continues to move, carrying air masses across the globe. This difference in wind speed and direction from the ground up is what meteorologists call vertical wind shear. It is not a storm by itself. It is not even a breeze you can feel. But it is one of the key ingredients that allows storms to become structured, steady, and sometimes gently rotating. Picture it this way. At the surface, the wind may be light, drifting from the south. 1,000 feet higher, it might be stronger, perhaps from the southwest. Even higher still, it may roar from the west or northwest, fast, focused, and smooth. These differences create twisting in the atmosphere, not violent turning, but a graceful corkscrew of air, rising slowly into the night. If a storm begins to form within this setup, it can stretch and tilt the twisting motion into rotation. The storm begins to organize itself, not into chaos, but into elegance. It spins softly, often hidden within clouds, flowing like a dancer on a quiet stage. This rotating motion doesn't always lead to severe weather. In fact, it often leads to longer-lived storms, storms that move with purpose, guided by upper-level winds. They may produce rain, lightning, or gentle thunder. They may glow with internal light, each flash revealing hidden structure within their cloud towers. At night, when the surface air is stable and the winds aloft are strong, this contrast makes wind shear more prominent. It becomes easier to detect, easier to sense in the language of the sky. Meteorologists use wind shear to predict which storms might become organized, able to sustain themselves for hours rather than minutes. And in the quiet of night, these storms may travel long distances, guided by these layered winds. But here, in the stillness of our story, wind shear is not a warning. It is a waltz. The air turns softly with height. It creates movement, not madness. It gives storm structure, not threat. Some of the most beautiful cloud formations are born in these sheared environments. Graceful anvil tops, long, curved inflow tails, delicate rolls along the base of a storm, and all of it happens silently, high above the sleeping world. So, as you rest now, perhaps you can imagine the sky above you, not as a single sheet, but as a stack of moving veils, each drifting its own way, each playing its part in the orchestra of the night. Wind shear is not something you need to fear. It is a part of how the sky breathes, and how storms dance. Let's drift onward now. Welcome once more, dear listener, to the Sleepy Meteorologist. Tonight, we look upward, beyond the quiet fields and rooftops, beyond the cooling air that brushes your skin, to a place you cannot see or feel, a layer that hovers high above, where warmth and moisture sometimes gather silently, building something extraordinary. This is the world of elevated convection. By nightfall, the ground often cools. The surface becomes calm. Winds slow, and the lower atmosphere settles. To the senses, it feels as though everything has gone still. But above this quiet, something else may be happening. Sometimes, a layer of warm, moist air lingers aloft, left behind by earlier weather systems, or brought in quietly by a gentle flow of air from distant places. This elevated layer, though invisible to the eye, can become a cradle for nighttime storms. Unlike typical convection, which starts at the surface, when warm air rises in bubbling columns, elevated convection begins higher up. It doesn't need the ground's warmth. It doesn't need a hot afternoon. It forms above the stable surface, in a space that remains softly unstable, gently buoyant. You might think of it as a second sky, a floating shelf of energy, waiting patiently for the right nudge. That nudge may come in the form of a gentle disturbance, a subtle ripple in the atmosphere, a shift in upper-level winds, something small, but enough to lift air within that elevated layer where moisture and warmth combine. And then, the clouds begin to grow. From the ground, these storms may appear distant, their bases unusually high. They hover like floating lanterns, casting no shadow. Often, they drift quietly, their lightning flickering from within, like a thought forming in the back of the mind. Because the storms are detached from the surface, they don't always produce rain where you are. You may hear thunder from far away, soft and rolling, but feel nothing on your skin. These are storms of the upper air, born in layers beyond reach. Elevated convection is a reminder that the atmosphere is not one single place, but many, layer upon layer, each with its own temperature, its own moisture, its own motion. And at night, those layers can become especially distinct. When surface air cools and becomes stable, it acts like a gentle anchor, keeping the lower atmosphere from rising. But above that, where the air is still moist and warm, the atmosphere remains open to motion. Clouds can rise, storms can grow. All of it happens overhead, quietly and elegantly. Meteorologists watch for signs of elevated convection in the temperature profile of the atmosphere, a kind of vertical fingerprint that reveals where the energy lies. Soundings taken by weather balloons often show a thin, warm layer nestled above cooler air, a perfect home for upper-level storms. These storms may seem detached from the world below, but they are very real. They carry rain, wind, and sometimes hail. They may appear on radar, like ghosts moving silently in the night. They remind us that the sky has secrets, that not all storms touch the ground, that not all power needs to shout. So as you rest beneath a clear or clouded sky, know that far above, in a space untouched by surface wind or warmth, a quiet ballet may be unfolding. Elevated storms, floating, flickering, and fading, with no need to ever touch the earth. Let the calm stay with you. Let the distance comfort you. And now, let's drift toward a deeper understanding of these night-born wonders. Welcome again to another quiet chapter of The Sleepy Meteorologist. Tonight, we meet a rare kind of visitor, one that forms not in spite of nightfall, but because of it. These are nocturnal thunderstorms, storms that do not fade with the setting sun, but awaken. There's something poetic about a thunderstorm born after dark. It glides across the land like a ship on invisible waters, glowing faintly from within, lit by silent lightning and guided by unseen winds. These storms don't rely on the sun's heat. They draw their energy from the memory of the day and from processes that are uniquely nocturnal, quiet shifts in wind, pressure, and moisture that unfold only after dusk. One of the key players in this nighttime story is something called the low-level jet, a stream of fast-moving air that often intensifies after sunset, just a few thousand feet above the ground. This jet acts like a conveyor belt, delivering warmth and moisture into the atmosphere from far-off regions, often from the south or southeast. During the day, friction with the Earth's surface slows the wind, but at night, as the surface cools and stabilizes, that friction weakens. The air above becomes smoother, and winds aloft can accelerate. The low-level jet emerges, strong, graceful, and quiet. This stream of moist air can ride over the cooler surface layer and feed instability in the elevated atmosphere. And when conditions align, when moisture, lift, and shear all come together, storms blossom in the night sky. These nocturnal thunderstorms may not start with great fanfare. There may be no booming thunder or sudden downpour. Instead, they form slowly, like a painting revealed in brushstrokes. Clouds rise quietly. Lightning pulses behind veils of vapor. Rain begins as a hush. Some of these storms grow into vast systems that travel hundreds of miles, what meteorologists call mesoscale convective systems, or MCSS. These organized collections of storms can form in the early evening and continue through the night, drifting across plains, valleys, and open countryside like glowing flotillas. From a distance, they look like soft, flickering horizons. From within, they are brilliant, each flash illuminating delicate cloud towers and curved inflow tails. And above all, they are steady. Nocturnal thunderstorms are often more persistent than their daytime counterparts. They are not easily disrupted. They follow the gentle guidance of nighttime winds. And yet, they carry no rush. They unfold slowly, moving with grace and purpose. They are the quiet heartbeat of the night's atmosphere, pulsing with energy in a darkened sky. If you've ever been awakened by distant thunder just before dawn, you may have heard one of these night-born travelers passing by. And if you've watched lightning dance across a midnight prairie, you've seen their artistry. These storms may never touch you. They may remain far away, part of someone else's weather, but they still shape the night. They still write their stories in cloud and rain and light. So, as you rest now, imagine them gliding silently, miles above, carried by the breath of the upper air. Let their quiet presence remind you that the sky is always in motion, even when the world below sleeps. Nocturnal thunderstorms are not intruders. They are artists of the atmosphere, painters of light, keepers of the night. Let's drift onward as they do. Hello again, friend, and welcome to Chapter 9 of The Sleepy Meteorologist. Tonight, we explore a hidden river in the sky, one you can't see, but it shapes storms, stirs clouds, and whispers across the night like a secret current. It's called the low-level jet, and it's one of the most powerful engines in the nighttime atmosphere. You may not feel it from where you are now, tucked in, grounded, still. But just above you, a few thousand feet in the air, the wind may be racing. As evening deepens, surface winds often slow. The air near the ground grows calm, cooled by radiational loss, settled by stability. Trees no longer sway, Curtains fall still. The land itself exhales. But in that soft stillness, something begins to stir higher up. Just above the surface layer, often between 1,000 and 5,000 feet, forms a narrow ribbon of fast-moving air. Meteorologists call it the low-level jet. It's not loud. It doesn't sweep through neighborhoods or bend trees. But up there, it moves swiftly, quietly feeding the atmosphere. What causes it? It's a combination of things. A gentle interplay of temperature contrasts, pressure gradients, and the Earth's rotation. But one of the key reasons it forms at night is simple. Friction fades. During the day, rough surfaces like trees, buildings, and terrain slow the wind through friction. But after sunset, as the surface cools and becomes more stable, the atmosphere decouples from the ground. That decoupling allows winds just above the surface to accelerate, no longer slowed by the clutter of the earth below. And so the jet forms, a sleek, streamlined current of air, often hundreds of miles long, but only a few miles deep. It moves quietly, but with purpose. This night wind plays a vital role in weather, especially nocturnal thunderstorms. It carries warm, moist air from lower latitudes northward, acting like a delivery system for storm fuel. Even when the ground has cooled and settled, the low-level jet continues its quiet work above, keeping the atmosphere primed for growth. It also enhances wind shear, the change in wind speed and direction with height. As we learned in earlier chapters, this shear helps storms organize, sustain themselves, and sometimes even rotate, like dancers guided by an invisible rhythm. The low-level jet can even create gentle lift as it overruns cooler surface air. This lift can nudge air parcels upward into buoyant layers aloft, triggering elevated convection and nighttime storms. And yet, despite its influence, the low-level jet is rarely noticed from the ground. You may hear the rustle of leaves stop. You may feel a stillness settle around you. But just above, a river of air is flowing, stronger than you might imagine, carving paths through the atmosphere. Pilots feel it. Weather balloons measure it. Storms respond to it. But to the rest of us, it remains a hidden engine of the night. Sometimes you might catch a clue, a nighttime thunderstorm that suddenly intensifies, clouds that build long after the heat of the day has faded, or a faint, warm breeze in the darkness that seems to come from nowhere. Those are the signs. The low-level jet is passing by. So tonight, as you lie in the comfort of still air, know that just above, the atmosphere is moving with grace, invisible, intentional, not in haste, but with quiet momentum. It is night wind's secret engine, and it hums softly onward. Now let's drift further into the mysteries of nighttime sound. Welcome back, gentle traveler, to Chapter 10 of The Sleepy Meteorologist. Tonight, we turn our ears to the sky. You may have noticed, on stormy nights, that thunder seems to rumble more deeply after dark. It echoes longer, rolls farther, and feels as though it fills the world. It's not your imagination, it's physics, and it's beautiful. To understand why thunder sounds louder at night, we begin where we often do, with cooling. As the sun sets and the earth releases its warmth, the air near the surface becomes cooler and denser. That stable air hugs the ground, smoothing out breezes, calming turbulence, and creating the perfect medium for sound to travel. You see, sound moves better through denser air. The molecules are closer together, allowing vibrations to carry more efficiently. During the day, rising warm air scatters and weakens sound. But at night, the cooling surface traps sound waves closer to the ground, allowing thunder to stay near your ears longer. The result is a richer, deeper rumble. Sometimes, this process is called sound ducting, as if the atmosphere has created a tunnel for thunder to roll through. Instead of dissipating quickly upward into a mixed daytime sky, thunder bounces gently between the ground and the inversion layer above, stretching its presence across neighborhoods and fields. That's why, during a nighttime storm, thunder might sound as though it's coming from every direction. It may begin as a low boom, rise into a crackling peak, and then trail off into a long, slow growl. Some even say thunder at night feels closer, more personal. You might hear it from storms that are still miles away, ones you cannot see but can sense. You might feel it softly in your chest before it fades into silence. Thunder also carries farther at night because background noise is lower. The world is quieter. No lawnmowers, no traffic hum, no daytime chatter. The stillness becomes a stage where every sound has room to breathe, and the cool, damp air of evening can amplify that sound even more. Moisture helps transmit low-frequency sounds, like thunder, with clarity and resonance. It's why a humid night feels so alive with sound. There is no need to fear it. Think of it not as a roar, but as a voice. The sky speaking slowly. Each rumble is a story of energy released, lightning's companion, echoing through layers of cloud and cool air. A sound that traces the path between cloud and earth. A sound that reminds you, the sky is always in motion, always communicating. Tonight, if you hear thunder, you can listen without worry. Let it roll over you like a soft wave. Let its echo fold into your dreams. Know that the atmosphere is simply adjusting, balancing pressure, temperature and charge, and leaving behind a lullaby of sound. There's no rush, no need to answer. Just receive the rumble and return to stillness. As thunder softens and fades into the distance, we too continue. Welcome back to another peaceful chapter of The Sleepy Meteorologist. Tonight, we rest our eyes on the sky itself, not to examine weather instruments or temperature charts, but to witness something beautifully simple, the way light reveals itself more vividly in darkness. This is the story of storm visibility at night. Have you ever noticed how lightning seems brighter after the sun has gone down? How even a brief flash can feel electric, as though the entire sky has blinked open for a second. It's not just your imagination, it's contrast. A deep, poetic contrast between light and shadow, energy and stillness. During the day, the sky holds brightness even when storms form. Sunlight softens the sharpness of lightning. Flashes compete with daylight. Clouds appear grey or white, outlined faintly against a blue backdrop. Beautiful, yes, but subtle. At night, the canvas changes. The sky becomes a deep well of black and navy. It wraps the world in velvet quiet. In that darkness, light is no longer diluted. It's free to shine in pure, undistracted brilliance. Every flicker becomes a spotlight. Every bolt, a signature. Even the faintest glimmer of electricity etches itself into the sky like a celestial engraving. This heightened visibility is part physical and part emotional. Without visual clutter, no glare, no sunlight, no shadows from buildings, the eye focuses entirely on the storm's luminous display. You can see the delicate structure of clouds illuminated from within. You can trace the outline of an anvil top. You might even catch a glimpse of mammatus clouds, glowing gently, like lantern pouches suspended in the sky. When lightning branches, the effect is even more striking at night. tiny forks stretch across miles, crawling through the clouds or flashing cloud to cloud in silence. Sometimes the entire horizon lights up, revealing details that had been cloaked just seconds earlier. The type of lightning also matters. In-cloud lightning, which stays within the cloud body, creates soft strobes that pulse like a heart behind gauzy curtains. Cloud-to-ground lightning, when visible, is sharper and quicker, sometimes cutting a jagged white path directly to Earth. At night, both types seem magnified in drama and detail. Storms that might have seemed far off or unimpressive in daylight now feel present, alive. It's not because they're stronger. It's because your senses are more attuned. The darkness heightens awareness. The contrast tells the story more clearly. Even radar and satellite imagery reflect this in a poetic way. Infrared satellite sensors can detect storm cloud tops cooling as they rise, even in total darkness. Meteorologists use those patterns to monitor storms long after sunset. The sky is always being watched, even when it sleeps. And yet, there's comfort in this visibility. It reminds us that even in the darkest hour, there is light. That storms are not monsters in the night, but intricate dances of temperature and charge. That when we pause and look up, we can find wonder. So the next time lightning flashes beyond your window, you can simply watch. Let it paint the sky for you. Let it flicker and fade like a thought passing through. It is not there to frighten. It is there to be witnessed. And in the silence between flashes, you can return to your breath, to your pillow, to your rest. Now, eyes soft, let's continue. Welcome again, friend, to The Sleepy Meteorologist. Tonight's chapter invites you to feel the air itself, not with your hands, but with your senses. The quiet softness of evening, the weight in the breeze, the gentle moisture that seems to settle all around you. This is the story of humidity and how it rises as night falls. As the sun dips below the horizon, the earth begins to cool. We've talked before about radiational cooling, the graceful release of stored daytime warmth. The surface loses energy and the temperature gently drops. But here's something lovely. The actual amount of moisture in the air doesn't change very much as the temperature falls. What does change is the air's ability to hold that moisture. Warm air can carry more water vapor. It has a greater capacity. As the temperature drops, the air's holding space shrinks, and so the relative humidity increases. That's what relative humidity means. It's not the total amount of moisture, but how full the air feels compared to what it could hold at that temperature. At night, with the same amount of moisture in a cooler atmosphere, that ratio rises. The result? The air feels thicker, softer, more saturated. You might notice it as dew on the grass, or a dampness on your skin, or the way your hair curls gently in the dark. The atmosphere draws closer. It wraps around you like a warm mist, even when the temperature drops. This elevated humidity plays an important role in nighttime weather. For one, it brings us fog and dew. As the temperature drops toward the dew point, the point at which air becomes fully saturated, moisture begins to condense. Water droplets form quietly on blades of grass, rooftops, and petals. The world gathers beads of water in silence. Sometimes a light mist rises from the ground, a shallow fog, not thick or frightening, but thin and silvery. A breath of moisture suspended just above the earth. But humidity does more than decorate the night. It can also influence storm behavior. As humidity increases near the surface, the atmosphere becomes more favorable for cloud formation. Moisture is a key ingredient in latent heat release, the process by which rising air condenses and gives off energy. This helps fuel storm clouds, even in a cooled nighttime setting. In some cases, high humidity helps maintain storms that formed earlier in the day. It keeps their environment supportive. It adds softness to the sky, both visually and structurally. And of course, elevated humidity affects how the night feels. It dampens sound. It thickens scents. It holds heat a little longer, creating warmer nights even after the sun is long gone. Some of the most iconic summer nights are marked by this humidity. Fireflies drifting through damp air, crickets singing in the soft warmth, distant thunder rolling through a heavy breeze. There is a fullness to it, a richness, and it's all connected to this quiet process: the cooling earth, the shrinking air capacity, and the steady rise of relative humidity. So tonight, as you breathe in, notice the texture of the air. It's not just empty space. It's filled with softness, with moisture, with quiet science. You're not just resting beneath the sky, you're part of it. And now, let us continue. Cool, calm, and humid. Welcome back, dear listener, to Chapter 13 of The Sleepy Meteorologist. Tonight, we explore contrast, not the kind that startles, but the kind that shapes the sky quietly, like layers of watercolor fading into one another. It's the difference between what we feel at the surface and what's happening far above. On calm evenings, the wind at ground level often slows to a whisper. Leaves barely stir. Grasses rest. The world feels wrapped in stillness. And yet, higher in the atmosphere, the air may be swirling with complexity. This is the story of calm winds below, chaos above, and how that contrast guides the way storms form, organize, and travel through the night. As the sun sets, radiational cooling begins to work its quiet magic. The ground releases heat, and the air closest to the surface begins to cool and settle. Cooler air is heavier, and so it pulls downward, forming a shallow, stable layer. Within this surface layer, the atmosphere becomes still. Friction with the ground has less energy to overcome, and wind slows. It feels peaceful, motionless, but only where we stand, because just a little higher, perhaps a few hundred meters above, the story is different. Above the inversion layer, winds may remain brisk, even turbulent. The daytime heating that stirred the atmosphere may have faded, but the momentum aloft hasn't. Jet streams continue flowing. The low-level jet may strengthen. Winds may begin to veer, changing direction and speed with height. This creates vertical wind shear, a gradual twisting and turning of air layers as you move upward. And it can give rise to powerful things. The contrast between calm and chaos is important in meteorology. It's not a contradiction, it's a relationship. That quiet surface layer can help anchor storms, creating a stable base from which elevated convection can rise. Meanwhile, the swirling air above provides fuel, lift, and structure. If a storm begins to form in that upper layer, the winds there can stretch and tilt it, helping it organize and persist. Instead of a quick burst of rain, you get a long-lived system, capable of moving for hours across the landscape. This difference in motion, what we call decoupling, can also explain why weather sometimes feels unpredictable at night. The air around you may be still and gentle, yet lightning flashes in the distance, thunder rolls, or radar shows fast-moving storms overhead. It's because you are sitting beneath the movement, cradled in the still layer, watching the sky perform above. Pilots are trained to expect this contrast. Flying just above the surface layer at night can feel turbulent as strong winds aloft meet the calm air below. But rise a little higher still, and the flight smooths out, riding the layered currents. And for the observer on the ground, it can be beautiful. Storms shaped by this dynamic may drift like dancers, calm and composed below, churning and active above. Their bases may remain high, their movement smooth, their lightning refined. So, if you ever step outside on a still night and see distant flashes on the horizon, know that the quiet around you does not contradict the chaos above. It complements it. It sets the stage for it. The surface has grown calm, but the sky still sings. Welcome again to this gentle journey through the sleepy meteorologist. Tonight, we look both down and up, to the ground beneath us, growing cool with the passage of time, and to the clouds above, which remain buoyant, alive, and glowing from within. This is the quiet tale of what happens when the earth cools, but the clouds stay warm, a balance that helps storms rise, thrive, and drift through the night. It all begins, as it often does, with the setting sun. As daylight fades, the surface begins its slow release. Heat gathered during the day seeps back into the atmosphere, lost to the open sky. Sidewalks cool, fields sigh. Rooftops, once hot to the touch, mellow into neutrality. But the air aloft doesn't cool as quickly. The clouds above, especially storm clouds, are insulated by moisture and lifted by dynamics occurring high above the ground. They are not grounded. They are not tethered to the Earth's surface. Temperature. They are their own world. This creates a contrast, a stable, cooling layer below, and a storm-sustaining layer above. Moisture plays a key role. As the ground cools, the air near it becomes more humid. We learned in Chapter 12 that relative humidity rises as temperature drops. This increased moisture becomes a gift to the clouds, rising gently into the upper layers, feeding their base with invisible streams of vapor. Storms love this moisture. It keeps them buoyant, helps maintain their structure, and contributes to latent heat release, the quiet energy exchange that occurs when water vapor condenses into cloud droplets. Even as the earth cools, clouds can stay warm, not from sunlight, but from within. Their warmth is not fiery or harsh. It is soft, stored, sustained by motion and moisture. This is especially true of nocturnal storm systems. Many are born from the day's lingering heat, but they're kept alive by the contrast between surface cooling and persistent warmth aloft. This temperature difference sharpens instability at specific layers in the atmosphere, just enough to keep air rising, clouds thickening, and rain gently falling. From the ground, you may look up and see these clouds illuminated by lightning, glowing towers in the dark. They seem so far away, untouched by the night, immune to cooling. But they are very much alive, carrying warmth, movement, and moisture through the chilled frame of the evening sky. And the ground, even as it cools, plays a part too. It anchors the system. It creates a layer of stability that keeps storms elevated, allowing them to drift without touching down. Sometimes, the cooling surface helps form fog or low clouds below the storms, painting a layered picture of the night. So the next time you see clouds moving gently above you while the ground is cool and still, know this is not contradiction. It is balance. The earth is releasing. The clouds are receiving. The sky is working quietly, in unison. And you, nestled somewhere in between, are part of this rhythm. Now, let us float with that warmth above and the coolness below. Welcome, gentle dreamer, to Chapter 15 of The Sleepy Meteorologist. Tonight, we follow the breath of a storm, its outward exhale, moving across the land just as the sky begins to dim. This breath carries a name, the gust front, and when it arrives at dusk, it paints the landscape with quiet motion. Let's begin with a storm already formed, suspended in the waning light. The sun leans low, casting amber shadows across rooftops and fields. High above, the storm pulses, tall and sculpted, its anvil drifting wide. Within its heart, rain falls, sometimes heavily, pulled downward by gravity and cooled air. That cooled air, now denser than its surroundings, plunges toward the ground. When it reaches the surface, it doesn't stop. It spills outward, spreading in all directions, like water poured from a bowl. This spreading air is what meteorologists call the gust front, a boundary that marks the edge where a storm's downdraft meets the surrounding atmosphere. It arrives with a sudden wind shift, a drop in temperature, and sometimes the scent of rain on distant soil. At dusk, the gust front becomes especially poetic. The setting sun casts long shadows across the land. Dust is kicked up in soft swirls. Leaves rustle. Birds settle back into trees, surprised by the sudden breeze. Sometimes, a line of clouds forms along the gust front, low, dark, and dramatic. These are Arcus clouds, and they often ride the leading edge like a cresting wave. But this gust of air isn't only beautiful, it's powerful. As it spreads across the landscape, it can lift warm, moist surface air into the cooling evening sky. That lift may be just enough to trigger new storms, igniting fresh convection at the edge of the older storm's reach. It's as though the storm is seeding new life as it fades. This is part of the atmosphere's elegant choreography. One storm breathes out, and that breath gives rise to another. The gust front becomes both an ending and a beginning. At the surface, you may notice the arrival of a gust front in several ways. The wind picks up suddenly. The temperature drops, perhaps 5 or 10 degrees in a matter of minutes. Dust may lift into the air, even when skies remain clear overhead. The scent of distant rain might waft through open windows. Sometimes, wind chimes ring briefly. Curtains stir. Leaves on the driveway begin their soft dance. And then, just as quickly, the gust passes, leaving a lingering hush. Meteorologists monitor these boundaries with great interest. On radar, gust fronts can appear as thin, arcing lines ahead of the main storm. They often march forward even after the parent storm begins to weaken. And in the warm, humid air of early evening, they can become catalysts for entirely new systems. To a storm, dusk is not a curtain call. It's a shift in the stage lighting. And the gust front, is the storm's final breath, stretching outward to touch what comes next. So tonight, as you lie in stillness, imagine that breath of air moving across fields, over lakes, through alleys and tree lines. Not violent, just certain, measured, calm. It cools the skin, stirs the grass, and offers the sky a second chance to sing. Now, let's float into the wake of those winds and follow their ghostly traces. Welcome again to The Sleepy Meteorologist. Tonight, we follow the ghosts of old storms, not spirits in the sky, but something more tangible, more meteorological, and just as mysterious. These are outflow boundaries, the lingering breath of a storm, moving quietly long after the clouds have faded. Imagine a storm that has already passed, its rain spent, its lightning stilled. The sky begins to open again. Perhaps stars peek through a thinning layer of cloud. The thunder has rolled into memory, but on the ground something remains. Outflow boundaries are created. when storms release cool air toward the surface. As this denser air spreads outward, like the gust fronts we met in Chapter 15, it marks the boundary between storm-cooled air and the warmer, undisturbed atmosphere ahead. Even after the storm itself dissolves, this boundary can linger, gliding forward slowly, sometimes for dozens of miles, sometimes for hours. It may be invisible, especially at night, but its effects are quietly real. You might not see it, but you might feel it. A gentle breeze from a direction that doesn't match the larger wind pattern. A sudden coolness brushing your skin, even beneath clearing skies. Leaves shifting with no storm in sight. These are the fingerprints of the outflow. On radar, outflow boundaries often appear as thin arcs or lines, expanding outward from the original storm. Meteorologists watch them closely, especially at night. Why? Because they can reignite the sky. Outflow boundaries can act like miniature cold fronts. When they push into warm, humid air, they provide gentle lift, just enough to spark new thunderstorms, especially after sunset, when surface air is moist and primed. It's like the sky remembering the energy it once held, and briefly recalling it. These boundaries can interact with other features too, like terrain, sea breezes, or even other outflows. When they meet, they can fold and curve, creating tiny eddies and lifting pockets. In the calmness of night, such interactions can quietly seed new storms. In this way, outflow boundaries are both remnants and catalysts. They mark what was and what might be again, and they drift silently, often without a sound. If you were to stand in an open field as one passed, you might feel a gentle shift in the air, a hush, a quiet push, a story told without words. Sometimes, low clouds form along them, a faint, rolling line. Other times, the boundary passes with no visual sign, only a brief stirring in the trees, or the feeling of coolness under the stars. They are often called storm ghosts for this reason. Not spooky, but lingering. Not loud, but meaningful. They are the sky's way of carrying memory forward, of letting energy move where it needs to, even after the drama has passed. So tonight, as you rest, imagine these boundaries drifting through the dark, carving gentle paths through humid air, touching the world softly as they go. They are not threats, they are transitions, and in their passage, the sky finds balance again. Now, we continue our own quiet movement. Welcome back, gentle traveler, to Chapter 17 of The Sleepy Meteorologist. Tonight, we explore a delicate balance in the sky. A quiet tension, a kind of invisible ceiling that keeps storms at bay during the day, only to release them when evening falls. This is the story of the warm air aloft, often called a cap, or, in more technical terms, a temperature inversion at mid-levels of the atmosphere. Let's begin where the sun is high and the day is warm. On the surface, heat builds hour by hour. Moisture thickens in the air. The landscape shimmers. It feels like a day ready for storms. And yet, nothing forms. The sky remains quiet. Clouds try to rise, but falter. The air feels heavy, expectant. This is the work of the cap, a layer of warm air higher in the atmosphere that acts like a lid. It prevents the warm, rising air from continuing upward. The cap resists vertical motion, pressing gently downward from above. You can imagine it like a sheet of warm glass suspended high in the sky. Beneath it, the lower atmosphere stirs with potential, but that sheet holds firm, keeping the energy trapped below. Why does this cap form? Sometimes it's left behind by a previous weather system, air subsiding or sinking, which naturally warms and dries as it descends. Other times, it's brought in by upper-level winds, transporting warm, dry air from faraway places, especially over the central plains. Whatever its origin, this cap creates a unique situation. The eel atmosphere becomes conditionally unstable, ready for storms, but waiting for release. And that release often comes after sunset. As the Earth cools, the surface air beneath the cap may continue to grow moist and restless. Meanwhile, winds may shift, disturbances may approach, and the cap itself may begin to weaken. Sometimes it's lifted by a passing front, sometimes eroded by moistening layers, sometimes broken by the subtle rise of evening thermals. And when it breaks, the change can be sudden. What was once calm and clear becomes dynamic. Clouds rise quickly, freed from their invisible prison. Storms ignite, often with impressive force. From the ground, this moment may feel almost magical. A warm evening suddenly dotted with thunderheads, clouds rising fast, their edges lit by the last pink light of day. Lightning begins to flicker. A hush falls, then a breath of wind. The release has begun. But this is not chaos. It is balance restored. The cap was not a failure of the sky. It was a holding pattern, a way to delay convection until the atmosphere could focus its energy more efficiently. Instead of many scattered storms during the day, a few strong ones may emerge at night, and they are often organized, powerful, and long-lasting. Meteorologists watch for these caps carefully. They appear in sounding profiles, vertical graphs of temperature and moisture. A telltale bulge of warmth at mid-levels tells us the sky is waiting, and so are we. So tonight, as you lie beneath the stillness of early evening, remember that some forces in the sky are quiet by design. They hold energy until the right moment, not out of tension, but out of timing. And when they release, the storms are not angry. They are simply responding. Now, let's follow those freed clouds. Welcome again to Chapter 18 of The Sleepy Meteorologist. Tonight, we observe something graceful, a meeting, a merging, a quiet joining of clouds in the upper air, far above the stillness of fields, rooftops, and lakes. This is the story of storm mergers after dark. In the afternoon, storms often form as scattered individual cells, each one rising from surface heat, fed by daytime instability. They are impulsive, bubbling up in patches, sometimes quickly, sometimes fading just as fast. But as evening comes and the surface begins to cool, the atmosphere begins to settle. That settling changes everything. With surface heating reduced, the lower atmosphere becomes more stable. But the layers above may still hold elevated energy, allowing storms to persist and even organize. And in this quieter setting, something beautiful begins to happen. Storms start to drift together. They follow upper-level winds, often gentle, steady flows that guide each storm toward others. As they approach one another, their outflows begin to interact. Rain-cooled air spreads across the landscape, nudging other storms forward. Cloud bases begin to align. Updrafts begin to synchronize. The atmosphere no longer hosts a dozen separate voices. It begins to hum with one deep tone. This is the beginning of a storm merger. Two or more cells, once separate, begin to feed from shared inflow. Their combined structure becomes more efficient. Rain areas broaden, lightning flickers more frequently, and the storm grows, not upward alone, but outward. These larger systems, called mesoscale convective systems, often form in the evening and travel through the night. They can stretch for hundreds of miles, glowing softly in satellite imagery like pulsing hearts in the darkness. Their rainfall may become more uniform, steady, gentle, even soothing, or it may intensify depending on the environment. But whatever form it takes, the merged storm becomes something greater than its parts. There is no rush to this process. The cells do not collide like waves. They drift, pulled gently together by shared conditions. And once merged, they move with grace, organized, balanced, directed. From the ground, you may notice an increase in wind as the system approaches, a brighter sky as lightning dances behind layered clouds. Rain begins to fall more steadily. Thunder settles into rhythm. But still, there is peace in this process. It is not a chaotic clash. It is a joining, a coming together of weather shaped by evening calm. Meteorologists observe these mergers with care. Radar tells the story in wide arcs of color. Satellites capture the slow spreading of cloud shields. And sometimes, these systems produce nocturnal thunderstorms that last well into the early morning hours, trailing rain, flickering light, and soft wind. You may sleep through it. You may hear it and feel safe. Or you may watch from your window, entranced by the sky's unity. So tonight, as your thoughts settle and your breath softens, imagine those drifting storms above, slowly finding one another, gently becoming something more. They are not a warning. They are a reminder that even in the night, things can come together. Let us continue beneath this larger sky. Welcome back, gentle listener, to Chapter 19 of The Sleepy Meteorologist. Tonight, we focus on a striking yet graceful visitor from the sky, lightning. Specifically, the kind that travels from the clouds all the way to the earth, cloud-to-ground lightning. And in the evening, when the air cools and the sky darkens, these bolts often appear more dramatic, more vivid, more unforgettable. Let us begin by returning to the balance of charge in a storm. As storm clouds build, invisible electrical charges begin to separate within them. The upper portions of the cloud become positively charged, while the lower parts gather negative charge. This imbalance sets the stage for lightning. It's nature's way of restoring equilibrium. During the daytime, this charge separation occurs just the same, but at night, something changes in how we see it, and sometimes in how it behaves. With sunlight gone, the darkened sky becomes a stage of perfect contrast. Each lightning strike cuts through that canvas with bold clarity. When a storm builds strong enough, especially in the evening, when upper-level winds support tall cloud towers, this electrical tension can discharge in spectacular ways. And some of the most dramatic discharges are those that extend downward, from cloud to earth. Cloud-to-ground lightning can appear as a single jagged stroke, or a complex web of branches. It may split and fork, tracing veins of light through humid air. These bolts are often golden white, tinged by the thickness of the atmosphere, or the scattering effect of late evening humidity. They do not just light the sky, they touch the land, connecting heaven and earth in a flash that lasts only milliseconds, yet feels suspended in time. Even more fascinating, the bolt you see doesn't strike first. Before the main return stroke flashes downward, a stepped leader of invisible, negatively charged air creeps towards the ground. From trees, rooftops, even blades of grass, tiny positive streamers rise to meet it. And when connection is made, the path opens. The visible bolt races upward through the path, creating that sudden burst of brilliance we know as lightning. At night, this entire dance unfolds in quiet majesty. Even small strikes appear monumental. They reveal the bones of the cloud above, frozen for an instant in light. Because the background is so dark, the brightness of even moderate lightning feels amplified. The same bolt that might go unnoticed in the afternoon becomes a centerpiece at night, etched into the memory of those who watch. You might feel it as much as see it, a soft tingling before it strikes, or a deep rumble that follows. The thunder, too, often rolls longer at night, traveling more efficiently through cool, stable air. And sometimes, when the air is especially humid, you can smell it, the faint scent of ozone and rain blending into the breeze after a strike. Cloud-to-ground lightning at night isn't more dangerous than during the day, but it certainly feels more profound. It reminds us that the atmosphere holds incredible energy that releases not with chaos, but with rhythm and purpose. You don't need to be near a storm to witness it. Sometimes, lightning can strike from miles away, a phenomenon called a bolt from the blue, arcing out of the storm's edge and down into unsuspecting ground. But here, in the stillness of your space, there's no need to worry. Just imagine it instead. A tall cloud in the distance, a hush, a flicker, a golden bolt, tracing a path toward the earth and vanishing into memory. It is not a threat. It is a reminder that even the sky needs to let go sometimes. Now, let's trace that energy outward. Welcome once more to Chapter 20 of The Sleepy Meteorologist. Tonight, we turn our gaze toward the edges of a storm, not the churning center or the rain-soaked core, but the elegant outstretched top, the anvil. And from that anvil, we witness something ethereal, silent arcs of lightning that stretch outward, far beyond the storm's heart. This is anvil lightning, light that travels away from the center, flickering across otherwise quiet skies. Let's start with the anvil itself. As strong thunderstorms rise, they reach higher and higher into the atmosphere, until they meet a boundary, a stable layer called the tropopause. It's the point where rising air can no longer go up, so instead, it spreads out. The result is a flat-topped, wide, spreading cloud formation that resembles a blacksmith's anvil, or a feathered veil in the night. This part of the storm can stretch for dozens of miles, sometimes even more, away from the main updraft and rain core. And from this elegant shelf, lightning can leap. Anvil lightning is also known as spider lightning, for the way it crawls across the sky, branching, curving, reaching from one part of the sky to another. Unlike vertical strikes, these flashes often travel horizontally, far from the storm's core, arcing silently above the earth. From the ground, it looks like a painting in motion. You may be standing under clear skies, surrounded by calm air, when suddenly the entire horizon pulses with light. It's not followed by sharp thunder. It's not part of a nearby downpour. It is a whisper from a storm, miles away. Anvil lightning is usually in cloud, meaning it stays within the cloud or moves across cloud layers without striking the ground. This makes it especially safe to watch, and particularly poetic. You might see it pulse behind high cirrus veils. You might see it cast momentary shadows on distant trees. Sometimes, it even lights the underbelly of the storm, revealing complex textures and rounded shapes called mammatus clouds. At night, this kind of lightning becomes more pronounced. The dark sky offers contrast. The cool, stable air near the surface carries the flicker more clearly. The result is a show that feels slow, sweeping, cinematic. Anvil lightning often travels so far that it precedes the storm itself. You may see flashes 30, 40, even 50 miles ahead of the rain, like quiet messengers, letting the sky know what's on the way. Meteorologists can track these flashes using lightning detection networks, which help them map not only where a strike occurs, but how far it traveled. Some of the longest recorded lightning strikes have spanned hundreds of miles, many of them through Anvil regions. But here in this moment, you don't need instruments or data, just your imagination, a quiet night, a horizon lit by arcs of silent electricity, a reminder that the sky is always connected, cloud to cloud, mile to mile, light to light. There's no need to interpret it, just feel it, the calm around you, the movement above you, the space in between. Let the arcs pass softly overhead as we follow them deeper into the nighttime sky. Welcome, friend, to Chapter 21 of The Sleepy Meteorologist. Tonight, we drift into the realm of one of the most powerful storm types the atmosphere can create, the supercell. And while many form in the heat of the afternoon, some of the strongest, most graceful supercells emerge in the calm of evening, guided by the quiet hand of wind shear and sustained by the day's lingering warmth. But don't worry, we are not here to sound alarms. We are here to observe the sky in stillness, to appreciate how even great power can move gently with structure and poise. So, what is a supercell? It is not simply a big storm. It is a storm with internal balance, a rotating updraft called a mesocyclone that allows the storm to organize itself, sustain itself, and glide across the landscape with steady purpose. Imagine a slow-turning spiral in the sky. Its clouds rise high, then curl outward in delicate anvil shapes. Beneath, the structure may seem quiet, even elegant, as it moves across the darkening land. Supercells need specific ingredients to form: moisture, lift, instability, and most of all, wind shear, the change in wind direction and speed with height. During the day, these ingredients often swirl together amid surface heat. But at night, the surface cools and the lower atmosphere begins to settle. You might think that would weaken storms, and sometimes it does. But under the right conditions, evening can enhance a supercell. Here's how. As the ground cools, winds aloft often grow stronger. The low-level jet intensifies after sunset, feeding warm, moist air into the base of the storm from just above the surface. This continued inflow helps sustain the storm's rotation, even as the surface grows still. And because the atmosphere is more stable at the surface, smaller competing storms often dissipate. The result? The supercell has room to breathe. It becomes the dominant presence in the sky, graceful, focused, and alone. From the ground, nighttime supercells are often cloaked in shadow. You may not see them clearly, but you might sense them. A shifting wind, the deep scent of rain and earth, the glow of distant lightning flickering through layered clouds, a low, continuous rumble that feels more like a purr than a roar. These storms don't rush, they rotate, slowly lifting warm air, spiraling it upward, feeding on that motion hour after hour. Some will weaken as night deepens, others will merge into larger systems. But for a time, they exist in balance, held between surface calm and upper-level motion. Meteorologists track nighttime supercells with radar and lightning detection networks. They appear as curved echoes, steady and sweeping. Sometimes they show a classic hook shape. Sometimes just a broad, smooth arc gliding across the plains. And you, here in this moment, do not need to know the science in detail. just the rhythm, the way the sky shifts, the way storms move when they are no longer driven by sunlight, but by momentum, memory, and structure. So tonight, if you hear thunder in the distance or see soft flashes far away, you may be witnessing a supercell, still spinning, still moving, still part of the evening's quiet work. It is not here to frighten. It is here to show you that even storms can be graceful. Now, let's travel onward into the broader welcome once more to Chapter 22 of The Sleepy Meteorologist. Tonight, we unfold into something larger, wider, slower, a weather pattern not made of one single storm, but of many, linked together, flowing as one. This is the story of the Mesoscale Convective System, or MCS, a broad, organized group of thunderstorms that forms and thrives after dark. An MCS isn't chaotic. It's not a swarm. It's a harmony. Think of it like an orchestra, individual instruments playing in coordination, building towards something steady and whole. During the day, storms may pop up here and there, small, energetic cells rising from surface heating. But as the sun sets and the atmosphere begins to cool and settle, some of these storms drift together. Their outflows combine, their updrafts align, and soon what was once scattered becomes connected. This is how an MCS is born. By evening, the surface is cooler, but layers above remain moist and warm. The low-level jet strengthens, feeding moist air into the system from just above the surface. Winds shift. The atmosphere grows more stable below, more dynamic above. And the MCS begins to grow, slowly, confidently. From above, it may look like a glowing cloud shield, smooth and expansive, moving steadily across the land. From radar, it appears as a curved line or broad cluster, often bowing forward as its winds strengthen. But from the ground, it feels like a long, soft rain, a rolling wave of thunder, lightning that pulses behind thick clouds, lighting the sky like breath. These systems don't race, they drift. They rain gently for hours, sometimes through the entire night, nourishing crops, cooling roads, softening the world. Some MCS events stretch across entire states, covering hundreds of miles. Others are smaller, affecting only a few counties. But no matter the size, they share a rhythm, a slow, deliberate pulse. Inside an MCS, individual storms may rise and fall like tides, updrafts lifting moisture, downdrafts spreading it outward. The system sustains itself, drawing energy from the very air it shapes, and the experience from below is often comforting. The rain is steady, not rushed. Thunder becomes background music. Lightning dances behind the clouds, never too sharp, never too sudden. It is a sleeping storm, moving while you rest. And in that motion is reassurance that the sky knows what to do, that storms, even large ones, can unfold with patience and grace. So tonight, if you hear the soft patter of rain on the roof, or see flashes behind curtains, know that you may be sleeping beneath an MCS, a nighttime system shaped by unity, not urgency. Let it soothe you, let it lull you, let it carry you gently through the night. Now, onward. Welcome back, gentle traveller, to Chapter 23 of The Sleepy Meteorologist. Tonight, we look toward the far-off edges of the sky, where flickers of light appear with no warning and no sound. These are not ordinary flashes. They are heat lightning, beautiful, distant sparks from storms too far away for thunder to reach your ears. They flicker like sky lanterns, lighting the dark horizon in silence. But let's clear something up gently. Despite its name, heat lightning has nothing to do with heat itself. it's not caused by warm air or summer temperatures, though it often appears on warm nights. It is simply regular lightning from a faraway storm. So far, in fact, that only the light can travel to you. The sound of thunder fades before it arrives. You may have seen it on a humid summer night, standing on your porch or lying beneath an open window. The sky flashes softly in the distance. There are no storm clouds overhead. The wind is still, but the light continues, occasional, glowing, like thoughts passing across the sky. This phenomenon is most common on calm, clear nights when your view stretches far. Storms may be 30, 50, even 100 miles away, too far for their thunder to reach you. But lightning light travels fast, and with little interference, it can reach much farther, especially when the air is humid and the horizon is wide. In this way, heat lightning feels almost ghostly, a trace of weather you cannot touch. You are not inside the storm, you are simply witnessing its light. Meteorologists sometimes call this distant lightning or non-local lightning, but in folklore, heat lightning remains a gentle name for it, evoking warm nights, quiet fields, and the stillness of dusk. The science is simple. Lightning generates both light and sound, but sound waves lose energy quickly. They bend, bounce, and fade in the lower atmosphere. After about 10 to 15 miles, thunder becomes faint, then silent. Light, however, travels freely. It cuts through moisture, curves over the horizon, and reflects off high clouds. Even if the storm is hidden behind hills or trees, its light may still reach you. And what a light it is! Sometimes, heat lightning pulses behind distant cumulonimbus clouds, lighting their outlines like paper lanterns. Other times, it seems to flicker out of thin air, no visible clouds, just flashes on the horizon, soft, colourless, and fleeting. There is something comforting about it. No rain, no wind, no sound, just a silent reminder that the sky is alive, even far away. You may feel a sense of connection in these moments, like watching a lighthouse from across the sea. The storm is not here, but it is somewhere, and its story travels to you as light. So the next time you see a flicker in the distance, with no storm in sight, don't be puzzled. You are seeing the sky remembering a storm. It is not a warning. It is not a mystery to fear. It is a whisper of weather. O altest quo, distant rhythm, carried on light. Let it be part of your calm. Let it flicker and fade. Let it lead us gently now. Welcome again, friend, to chapter 24 of The Sleepy Meteorologist. Tonight, we rise high, up to the very tops of towering storm clouds, where temperatures drop and electric energy quietly builds. This chapter is about cooling cloud tops and how, at night, they can lead to brighter, more frequent lightning. Let's drift upward together. Storm clouds are born from rising air. Warm, moist parcels of atmosphere lift skyward, cooling as they go. As they rise, the moisture inside them condenses, forming clouds. If the air continues to rise, the cloud grows taller, until it reaches the upper atmosphere, often more than 30,000 or even 50,000 feet high. At these heights, the air is cold, very cold, and as the cloud top cools, something interesting happens. Its electrical potential increases. That's because the top of a cloud holds positive charges, while the bottom often holds negative charges. The greater the temperature difference across the cloud, the stronger this charge separation becomes. And strong charge separation, that's the recipe for more lightning. At night, this process can intensify. Without the sun's influence, the upper atmosphere cools even more. The tops of storms lose heat rapidly, especially in clear, dry air. This enhances the temperature contrast between top and base. And the stronger that contrast, the more electrical energy builds inside the cloud. You might not feel it from below, but you'll see it. Lightning becomes sharper, brighter, more frequent. Flashes ripple across the cloud canopy. Forked bolts dive toward Earth. Spider-like arcs spread across the sky, chasing one another from tower to tower. To meteorologists, cooling cloud tops are a clue. They often monitor these temperatures using infrared satellite imagery. Clouds that cool rapidly and deeply show up in deep shades, sometimes black or dark red on the display. These cold tops are a signal that a storm is strengthening. It's like the storm is growing taller and colder, and in doing so, it grows more electric. This is why lightning sometimes intensifies after sunset, even as surface temperatures fall. It's not about heat at the ground. It's about what's happening miles above, in the deepening chill of the upper sky. And from the ground, the display can be mesmerizing. Clouds light up from within like lanterns. Each pulse reveals textures, pillars, folds, domes. Thunder follows with rhythm, not panic. It becomes the slow heartbeat of the sky. Sometimes the lightning is so frequent that it feels like a silent strobe, flashing every few seconds, creating a light show hidden within the clouds. And all of it is powered by cooling, not a violent act, but a natural release. Energy builds, energy shifts, the sky adjusts itself, one spark at a time. So tonight, as you rest beneath it all, know that even the brightest flashes are born from balance, from warmth rising and cold settling, from the storm breathing into the night. You may see the light, you may hear the thunder, but you are safe, grounded, and still. And as those cloud tops cool and shine above you, you can drift deeper. Welcome back to Chapter 25 of The Sleepy Meteorologist. Tonight, we slow things down even more, to a moment in time that often passes without notice, a moment of stillness. This is the quiet before a storm. Not dramatic, not cinematic, just calm. Eerie, perhaps, but more than anything, patient. You may have felt it before, that strange hush that settles before an evening storm arrives. The air softens, birdsong fades, leaves hold their breath. Even the sky seems to pause. This is not just poetry. It's a real and measurable moment in meteorology. It happens when a storm approaches, but hasn't yet arrived. A kind of balance forms, like the atmosphere waiting for its cue. Let's ease into the science behind this calm. As a storm builds and draws nearer, it begins to pull air into its structure. This inflow moves quietly across the surface, smooth, steady, and directional. It's not a gusty wind, it's a soft inward breath. At the same time, warm, moist air near the ground begins to rise more slowly. The energy of the day is winding down. The surface has begun to cool, and the atmosphere seems to say, wait. This pause in motion can lead to a striking stillness, not just physical, but sensory. Sounds become muted, shadows grow long. Birds, sensitive to pressure changes, often quiet down. Insects pause. Even pets may turn their attention upward, sensing something subtle in the shift. The sky changes too. Clouds that were scattered and soft may begin to gather, thickening along the horizon. The air grows heavy, not oppressively so, but noticeably, and light takes on a strange quality, sometimes golden, sometimes silvery, sometimes tinged with blue-grey. It's as if the atmosphere is holding its breath. This moment is brief, but it can be deeply felt. In weather terms, it's the inflow phase, when a storm draws energy inward but hasn't yet released its rain, wind, or lightning. There may be pressure falls near the surface as the storm approaches, or a cap still holding convection at bay. The energy is there, but it hasn't been freed yet. For many, this stillness becomes a memory, a childhood evening on a porch swing, a quiet lake before distant thunder, a moment of pause before rain whispered across the rooftops. And while some describe it as eerie, it is simply nature balancing itself before the next chapter begins. So tonight, if you feel that quiet, that lull, that waiting space in the air, know that it's not an omen. It's a part of the process. The atmosphere is not frightened. It is focused. It is transitioning. And you too can pause in that space. Breathe deeply. Feel the stillness. Let your thoughts rest with the windless air. The storm will come. It will rain. It will speak. And it will pass. But for now, the quiet holds you. Let us drift with that calm into something higher still. Welcome again to Chapter 26 of The Sleepy Meteorologist. Tonight, we look up into the smooth, layered sky of evening, and we find motion where we least expect it. Ripples, drifting silently across the atmosphere. These are gravity waves, not to be confused with the gravitational waves of deep space. These are much closer, gentle pulses that ripple through the air itself, like waves across a sleeping lake. They are born when something disturbs the atmosphere's balance, and often that something is a storm. Let's begin there. Picture the atmosphere in the evening, stable, settled, and layered like silk sheets. Cooler air near the ground, warmer air above, and a sense of stillness that stretches for miles. Now imagine a powerful thunderstorm punching upward into those layers, rising fast, churning, sending its cloud towers into the upper atmosphere. That rapid motion creates a disturbance, like tossing a stone into a calm pond. The result? Gravity waves. These waves are not made of sound. They don't roar or gust. They are made of air density, rising and falling in gentle pulses. They ripple outward from the storm in rings or arcs, moving horizontally, sometimes for hundreds of miles. Sometimes they move through clear skies. Sometimes they sculpt clouds into delicate shapes. And sometimes they can be seen. Have you ever looked up and noticed bands of clouds, evenly spaced, arcing across the sky like the ribs of a shell, or ripples in cirrus clouds that seem to radiate from a point on the horizon? That's gravity waves at work. They can shape altocumulus undulatus, beautiful, wavy mid-level clouds that appear like brushstrokes across the twilight, or roll clouds, or waves trapped between layers of stable air, moving without sound. At night, when the atmosphere is calm, these waves travel farther. Without daytime turbulence to break them apart, gravity waves remain coherent, flowing gracefully through the upper sky. They often spread out from large storm complexes, MCS systems, or supercells, or even mountain ranges. You might see their effect just after sunset, rippling cloud arcs glowing with the last golden light, or faint silver streaks beneath moonlight. Or, if you can't see them, you might simply feel their rhythm in the subtle shifting of the wind. To meteorologists, gravity waves can be both fascinating and useful. They can enhance lift, helping new storms form, or they can suppress convection, quieting the sky. They tell us how energy travels, not chaotically, but in elegant wave-like motion. But for us, here tonight, they are simply something to watch, to imagine, ripples of air drifting across the layered sky, shaped by storms, held by gravity, unseen by most, but always present. So, the next time you see soft waves in the clouds, or feel a rhythm in the wind that has no sound, you may be witnessing one of these sky-bound waves, gentle, vast, and unhurried. Let them carry you now. Let them rock you lightly, like the sky rocks its own layers. And as the waves roll quietly above, we drift onward. Welcome back, dear listener, to Chapter 27 of The Sleepy Meteorologist. Tonight, we close our eyes and listen, because sometimes the most telling signs of approaching weather don't come from the clouds, but from the creatures that live among the trees, the grass, the soil. This is the story of cicadas, and how they often fall silent before a storm. As dusk settles across a summer evening, you might hear their hum, that rising, shimmering chorus that seems to come from every direction. Cicadas, with their steady rhythm, create one of the soundscapes most deeply tied to warm, quiet nights. Their song is constant, until it suddenly isn't. Just before certain nighttime storms arrive, the familiar drone of cicadas and other insects can fade into an unexpected hush. The sound softens, then stops. The silence, somehow, says more than the song. But why does this happen? It begins with the air. Before a storm arrives, the pressure begins to drop. Subtle changes occur in humidity, wind, and temperature. The atmosphere holds its breath, and the natural world feels it. Cicadas, like many insects, are sensitive to environmental cues. They have tiny sensors in their bodies, organs that help them detect changes in barometric pressure. These minute drops in pressure signal instability, a shift in the air's behavior, a message written on the wind. To us, it may go unnoticed, but to a cicada, it's a cue. It tells them something is coming, a shift, a storm, something that suggests it's time to quiet down. Just as birds often take shelter or fall silent before weather changes, cicadas seem to pause their song in anticipation. It may be instinctual, a defense mechanism from their ancient past, or simply a biological response to physical discomfort. The sudden drop in temperature that can arrive ahead of an outflow boundary may also play a role. Cicadas thrive in warmth. Cool air slows them. Their muscles tighten. Their rhythm softens until the chorus dissolves into silence. It's a different kind of forecast, one without radar, without charts, just a forest listening to itself. This silence doesn't always last long. Sometimes it returns after the storm has passed. Other times, the rain cools the evening enough that the cicadas simply stay asleep, waiting for the sun to warm the world again. To the human ear, this shift can feel profound. There is something both mysterious and grounding about the sudden absence of sound, the silence before the rain. It invites you to notice everything else: the rustle of a single leaf, the soft static of wind through tall grass, the pulse of distant thunder, now easier to hear, the way the world seems to lean inward. And in that moment, we listen too. So tonight, if you find yourself outside beneath a dusky sky and the cicadas stop singing, know that they are listening to the storm before you can see it. They feel the pressure drop. They sense the breath of cool air. They fall silent, not in fear, but in knowing. Let that silence guide you inward, not to worry, but to wonder. The storm will arrive or pass by, but in this moment, you can be still and listen to the air. Let's carry that stillness forward. Welcome again to Chapter 28 of The Sleepy Meteorologist. Tonight, we follow the breath of a storm, not the storm itself, but what it leaves behind. A soft surge of cool air, spreading, gliding, and sometimes quietly sparking new storms. This chapter is about outflow sparks, moments when a storm's exhale becomes another's beginning. Let's begin at the end. A mature thunderstorm has already formed, risen tall into the evening sky. Rain falls in sheets. Downdrafts plunge from cloud to earth, carrying cold air with them. When that air hits the ground, it can't go farther down, so it spreads out sideways. This is the outflow, a gentle but far-reaching boundary that moves ahead of or away from the storm itself. The outflow is cooler than the air it meets. It spreads like water across warm ground, rippling across open fields, highways, forests, and lakes. Sometimes it brings a chill, a sudden breeze, a change in scent, but it also brings something else: lift. As this cooler air pushes under warm, moist air already present at the surface, it forces that warm air to rise. And if the atmosphere is unstable enough, if the air above is ready, new storm clouds may begin to form. This is how old storms breathe new life. Meteorologists call these boundaries outflow boundaries or gust fronts, and they're often seen on radar as thin, curved lines ahead of the main storm. But they're more than just lines. They are spark zones, where outflow meets ripe air. New clouds can bubble upward. They start small, wisps of rising cumulus, then deepen, thickening into towers. And soon, lightning may flicker again, miles from where the original storm began. It's as if the storm passed its torch, handing energy forward through breath alone. This phenomenon is especially common at twilight, when the lower atmosphere is still moist from daytime heat, and the outflow air glides across it like a dancer across a stage. Sometimes, outflows from multiple storms can collide. When they do, the convergence can create even more lift, igniting entire clusters of storms that weren't there just moments before. And still, the surface may remain calm. You may not hear the source. You may not feel the origin, but the storm grows, born not from sunlight, but from memory. This is how the atmosphere keeps its rhythm. One system exhales, another responds. A chain of breath and lift, of cool air and rising moisture, playing out across the land. To you, it might begin with a sudden breeze, a cool draft on your cheek, a stirring in the trees, and then, minutes later, clouds rising, light flickering, a storm beginning again. But this isn't chaos, it's continuity. The sky remembers, the clouds respond. So, tonight, as you lie still beneath the ceiling of stars or the veil of night clouds, remember, even when something ends, it may begin again, quietly through a single breath. Let that comfort you. Let us drift now with the wind that carries us. Welcome back, friend, to Chapter 29 of The Sleepy Meteorologist. Tonight, we turn our attention to a simple truth beneath our feet, the warmth of the earth, and how, when paired with a cooling sky, it creates one of the quietest invitations for clouds to rise. This is the story of warm earth and cool sky, a natural recipe for lift. As evening deepens, the sun slips below the horizon and shadows stretch long across the land. But the earth doesn't lose its warmth immediately. It remembers the day, soil, roads, rooftops, and grasses each holds a bit of heat, like coals under ash. The sky above, however, begins to cool more quickly, especially the layers just above the surface. Without sunlight, the atmosphere releases its energy upward, quietly, steadily. This sets up a beautiful contrast. Warm below, cool above. And in this imbalance, something magical can happen. Lift. Warm air near the surface begins to rise, slowly, softly. It isn't a dramatic surge, but a gentle push. A parcel of air, warmed by the earth, becomes slightly lighter than the air above it, and so it floats. This process is known as convective lifting, and it's one of the key ways clouds begin to form. The rising air cools as it ascends. If it's moist enough, that cooling causes condensation, and condensation creates clouds. It may begin with a faint wisp, barely visible against the darkening blue. Then a small cumulus, and perhaps, eventually, something taller. At night, this process slows down. But under the right conditions, if the air remains moist and the cooling above continues, a layer of weak instability can form. These subtle layers aren't always visible, but they're there, encouraging just enough upward motion to allow elevated storms to grow, or fog to form, or haze to linger in low places. It's a kind of gentle imbalance, just enough to keep the air moving upward. Sometimes the effect is localized, in valleys where warm air pools, over fields where the ground retains heat just a little longer than the woods around it, or in cities where concrete radiates warmth well into the night, what meteorologists call the urban heat island effect. In these pockets, lift can linger, and where air lifts, clouds follow. You may not see it as a storm, you may not hear it, but the sky is always adjusting, balancing temperature and motion, rising and settling, drifting and clearing. To the trained eye, this dynamic shows up on weather soundings, gentle curves in the temperature profile, slight deviations between temperature and dew point. To the rest of us, it may feel like a subtle shift in the air, the soft breath of the earth giving rise to evening clouds. So, tonight, if you feel a warmth in the pavement beneath your feet and a coolness at your cheeks, you're standing in that balance. And if you see a lone cloud rising above a quiet field, know that it's been lifted gently by the warmth below and welcomed upward by the cool air above. A quiet invitation, a rising thought, a sky remembering the warmth of the ground. Let's rise with it now. Welcome once more to Chapter 30 of The Sleepy Meteorologist. Tonight, we look west, where the sun has already dipped below the horizon, but its light still lingers. This is the afterglow, the final act of sunset. And when that fading light meets towering thunderheads, something extraordinary happens. It begins with color. As the sun sets, its light travels through more of the Earth's atmosphere. Shorter wavelengths, blues and greens, scatter away. What remains is the longer light, reds, oranges, and golds. These hues bathe the undersides of clouds, especially tall ones, in radiant tones. And few clouds are taller or more dramatic than thunderheads. A thunderhead, or cumulonimbus, rises tens of thousands of feet into the air. Its top may be flattened into an anvil, its base hidden in shadow, its body sculpted by air currents and moisture. And when the afterglow touches it, the cloud becomes a canvas. Ridges of vapor catch deep pink. Edges shine with copper and rose. The high anvil glows pale gold, then lavender. Even stormy clouds become beautiful. This contrast between the soft colors of light and the power within the cloud is one of the sky's quiet paradoxes. Inside the thunderhead, lightning may still be flashing, rain may still be falling in distant sheets, thunder may still rumble, far off, like a drumbeat behind velvet curtains, and yet, from afar, the whole structure glows. It's a reminder that storms are not just noise and motion. They are sculptures of air and light, shaped by energy yes, but also by elegance. The afterglow is brief, lasting only minutes, but its effect lingers in memory. Photographers chase it, poets write about it, and you can simply witness it. From a window, from a quiet walk, or from a memory. Even after the sun has set, its light travels upward, meeting the tallest clouds, those that have climbed high enough to catch the day's last rays. And so the storm is painted, not in grayscale, but in crimson, gold, and soft flame. As evening deepens, the colors fade into blue. The thunderhead, once glowing, becomes shadow. The lightning within becomes clearer. The storm shifts from art to sleep. But in that twilight moment, when the sun's memory meets the storm's body, you are witnessing something rare, a meeting of calm and energy, of light and motion, of stillness and power. So tonight, close your eyes and picture it. A thunderhead glowing rose in the west, the hum of insects returning, the final warmth on the horizon, and the slow, sure settling of night. Let's carry that image with us now. Welcome back, gentle dreamer, to chapter 31 of The Sleepy Meteorologist. Tonight, we shift our attention skyward, not to feel the storm, but to observe it, from a distance, with care, with quiet tools that let us see patterns too slow, too vast, or too high to notice on our own. This is the world of nocturnal storm tracking, the subtle art of following storms through the night. As daylight fades, the tools we use to watch the weather become even more valuable. We cannot see the horizon as clearly. The clouds vanish into black, but still, the atmosphere moves, and high above, meteorologists watch it unfold like slow calligraphy across the sky. They use radar, pulsing quietly from the ground, sweeping in circles like lighthouse beams. Radar sends out invisible signals, brief bursts of energy that bounce off raindrops, hail, and even dust. What comes back is not sound, but information, a story in motion. At night, radar becomes the meteorologist's lantern. It reveals what the eye cannot. It shows arcs of rain, towers of hail, lines of gusty wind. Each sweep paints a picture, a frame in the sky's quiet animation. But radar alone is not enough. High above, satellite imagery offers another perspective. Orbiting the Earth silently, these watchers from space look down and see the shape of cloud systems, their depth, their texture, their temperature. During the day, satellites show visible images, clouds reflecting sunlight, shadows stretching across the land. At night, they switch to infrared, detecting the temperature of cloud tops. Cold clouds glow bright white. Warmer ones fade to grey. The coldest cloud tops, often the tallest thunderheads, appear as dark shapes on glowing screens. This helps forecasters know this storm is still strong. This one is fading. That one is growing. The combination of radar and satellite is like reading two pages of the same story, from different angles, one from within, one from above. Sometimes, meteorologists also use lightning detection networks, which map the exact location of each lightning strike. Even the soft flicker you see on the horizon can be traced. Its type, its length, its reach, and all of it is recorded in near real time. In the stillness of night, the atmosphere's story becomes easier to follow. With fewer daytime thermals, fewer scattered clouds, and fewer small storms, the larger systems take center stage. Lines of convection stretch across counties. Clusters of thunderstorms drift eastward. Outflow boundaries curl like tendrils. It all unfolds slowly, like ink flowing across paper. And from quiet rooms, lit by monitors and maps, meteorologists watch it all. Not with alarm, but with care. They note changes, update guidance, trace movement, and provide soft warnings where needed. Just enough information to help others rest easy. To the rest of us, this might all go unnoticed. You might be asleep while a storm crosses 3 counties. You might hear thunder and roll over, never knowing its name or shape. But overhead, the sky is being read, not as noise, but as language. So tonight, if you hear a distant rumble, know that someone, somewhere, is following that storm, not chasing it, but listening to it, interpreting its curves, tracing its breath, watching it write its presence across the canvas of night. And with that quiet assurance, welcome again to Chapter 32 of The Sleepy Meteorologist. Tonight, we explore a gentle paradox. We often think of night as the end of weather's performance. The sun fades, the heat dissipates, the winds slow, and yet, some storms, instead of weakening, grow stronger, more organized, more enduring. This is the story of why some storms last longer after dark. Let's begin with a simple idea. Storms feed on instability, the contrast between warm, rising air and cool air aloft. During the day, surface heating drives much of that instability, but after sunset, the surface cools and the atmosphere stabilizes. So why do some storms persist? The answer lies not at the ground, but above it. In the evening, the cooling of the surface air often creates a stable boundary layer near the ground. This layer slows down rising motion from below, calming small or weak storms. But above that layer, the atmosphere may remain rich with energy, warm, moist, and gently unstable. Storms that formed earlier in the day, especially if they grew tall and mature, often lift their roots into these higher layers. They become elevated storms, no longer relying on surface instability. They feed from above, and in doing so, they become more independent of the cooling earth. This decoupling allows them to drift longer, live longer, and in many cases, organize more clearly. There's also the low-level jet, that narrow ribbon of fast-moving air that often strengthens after sunset. This jet delivers moisture and momentum into the storm's base, keeping its updraft strong, even in the absence of surface heat. And without daytime chaos, no scattered small storms, no gusty thermals, these nighttime systems can evolve into something smooth, more elegant, more focused. They may expand into a mesoscale convective system with layered rainfall and steady wind. Or they may remain as individual supercells, rotating quietly through the night. Either way, their structure becomes more defined. Their lifespan stretches beyond sunset, and they continue to move across counties, sometimes states, long after the world below has gone to sleep. To you, the presence of these storms may be subtle. You may wake to find the road wet, or hear rain patter at midnight, or watch lightning flicker behind the curtains. It may feel like the storm has lasted forever, but in truth, it's just a well-structured guest, riding the rhythm of the nighttime sky. These storms aren't anomalies. They are part of the natural cycle, when the quiet above meets the moisture below in perfect balance. So tonight, if the storm continues longer than you expect, don't wonder why. It is simply held together by the calm above and the memory of heat below. It is gliding on quiet winds. It is sustained, not shaken. Let that knowledge settle over you like a blanket. The storm may last a little longer, but so will your peace. Now, onward. Welcome back, gentle listener, to Chapter 33 of The Sleepy Meteorologist. Tonight, we sit in the stillness beneath an unusual sky. A sky where the clouds flash, but no rain falls. Where lightning glows, but your window remains dry. This is the quiet experience of lightning without rain, and it happens more often than you might think, especially at night. To understand it, we must drift upward to the world of elevated storms. These are thunderstorms that form above the cooled surface layer. They float higher in the atmosphere, detached from the ground, like ships gliding across a sea of invisible air. They are often born after sunset, when the surface has stabilized and small surface-based clouds can no longer grow. But aloft, the air may still be warm, moist, and buoyant, especially near the low-level jet. These upper layers offer just enough lift and moisture to keep convection going. Clouds rise, charge builds, and lightning begins to flash, bright, electric, and clear. But the rain these storms produce may never reach the ground. This happens when the layer of air between the storm and the earth is too dry or too stable. As the rain falls, it evaporates. The droplets become vapor long before they can touch the surface. This phenomenon is called virga, precipitation that falls from a cloud but evaporates before arriving. You might see it as faint streaks beneath clouds, lit up by lightning, trailing down like soft grey threads, then vanishing into the air. The result? A storm that glows and rumbles, but never wets your skin. You may hear thunder, low, distant, and delayed. You may feel a breath of cool air, the outflow from the storm spreading across the landscape. The breeze carries the scent of rain, but none falls. You might stand outside beneath stars, watching the horizon flicker. You may see anvil lightning stretch from cloud to cloud, arcing across the sky in great silver ribbons. The experience feels surreal, as if the storm is happening in another world, just close enough to witness. And in a way, it is. Lightning without rain can feel like a mystery, but it is simply the atmosphere's way of continuing its quiet work, balancing energy, shifting moisture, letting go of charge. It is not a failure of rain, but a triumph of structure, a sign that storms do not need to touch the ground to leave an impression. Some cultures once believed that lightning without rain was a message, a sign from the gods, or the ancestors, or the earth itself. And while we now understand the science behind it, the feeling remains. It is a kind of reminder that even when nothing seems to fall, something important is happening above. So, tonight, if you see a flicker, but hear no thunder, or feel no drops, know that you are witnessing an elevated performance. A storm walking quietly overhead, leaving behind only light and a breath of cool wind. Let it flash without fear. Let it pass without sound, and let us drift. Welcome once more to Chapter 34 of The Sleepy Meteorologist. Tonight, we step into a moment between endings. The storm has passed, but the sky still speaks, and while thunder fades softly in the distance, something delicate begins to form on the ground. Dew. This is the story of dew and thunder, two opposites sharing the same night. After a storm moves through, the air is often rich with moisture. Rain may have fallen, clouds may have passed. The world feels rinsed and fresh. And then comes the cooling. Without the sun, the earth begins to release its stored warmth. The ground, rooftops, and leaves radiate heat upward into the night. The air touching them cools too, gradually sinking toward its dew point. That's the temperature at which air becomes saturated and can no longer hold all its moisture as vapor. Instead, tiny droplets begin to form, not as rain, but as dew. You may not feel it forming, but in the early hours, it appears like magic on the blades of grass, on windowsills, on petals, spiderwebs, garden chairs, and fences. And while this quiet condensation begins, something else remains: the distant roll of thunder. It may be soft, it may be delayed, it may echo across hills or city blocks, but it is still there. The storm itself may be miles away now, drifting eastward or weakening, but the sound lingers, like a lullaby trailing behind a slow departure. This contrast between thunder in the sky and dew on the ground is something truly special. One speaks of motion, the other of stillness. Thunder reminds us that energy is still moving, while dew tells us the night is settling into calm. You might step outside and feel the moisture on your skin, cool and refreshing, while lightning flickers far beyond the horizon. Or lie in bed with the window cracked open, the soft scent of damp earth rising, while the last murmurs of the storm speak low in the distance. It's a moment of peaceful coexistence, and for meteorologists, it's also a sign of harmony in the atmosphere. The storm has done its work, lifting moisture, releasing heat, balancing pressure. Now the sky allows itself to cool and quiet, and the earth responds in kind, gathering droplets in silence. In some places, this process brings fog. In others, just a freshening of the world. But in all, it is part of the same cycle, a release, followed by renewal. So tonight, if you hear thunder as you drift to sleep and wake to find the world beaded with dew, you've witnessed both parts of the story. The motion and the rest, the echo and the exhale. Let that contrast soothe you. Let it remind you that even the sky has rhythms. Even storms make space for stillness. And now, with dew gathering and thunder drifting, we continue. Welcome back, gentle friend, to chapter 35 of The Sleepy Meteorologist. Tonight, we step into the quiet that follows. The clouds have broken, the thunder has faded, and in the hush that lingers after the storm, something soft begins to rise. This is the story of fog after the storm, a gentle return to stillness as the earth exhales and the sky leans close once more. It begins at the surface. A storm passes through, cool rain falling on ground still warm from the day. The contrast is instant, but not loud. It's a meeting of temperature and moisture, of calm and motion. The rain cools the air, but also leaves behind its gift: saturation. The air becomes heavy with moisture, full, satisfied, and ready to settle. As the storm moves on, the ground remains damp, pavement glistens, fields shimmer, leaves are jeweled with raindrops, and then something delicate begins. The earth releases its heat, gently, steadily. The surface cools, and as the temperature dips toward the dew point, the air can no longer hold all its moisture as invisible vapor. So it lets go. Tiny droplets condense, first low to the ground, then rising like breath. Not rain, not cloud, but fog. This kind of fog is called radiation fog, born from a cooling surface and a saturated sky. It forms most easily on calm, clear nights just like this one, after a passing storm has cleaned the air and slowed the wind. You may step outside and see it hovering above the grass, or drifting across fields, or collecting in valleys like silver water. It softens the world. Familiar outlines blur. Street lamps glow in halos. Trees become shadows. Voices carry farther, and everything feels just a little slower. Fog after a storm is not a threat. It's a comfort. A signal that the atmosphere is balancing itself again. The rain may have stirred the sky. The wind may have scattered the leaves, but now the earth is healing, and fog is its lullaby. In meteorological terms, fog tells us that the air near the surface has reached saturation, that cooling and condensation are working in perfect harmony, that stability has returned. Sometimes fog forms only briefly, burning off quickly when the sun rises. Other times, it lingers into dawn, coating the world in mystery and moisture. You may smell the richness of the soil. You may hear only your own breath. You may feel the dampness on your skin, like a whisper. And overhead, the storm has vanished. Only silence remains, a curtain drawn softly across the night. So tonight, if you wake and peer out your window and see the soft veil of fog covering the ground, know that it was born of rain and calm, of warmth and release. It is the storm's final sigh. Let that softness surround you. Let it muffle the world. Let it wrap you like mist wraps a field. And now we continue. Welcome again to Chapter 36 of The Sleepy Meteorologist. Tonight, we reach the heart of night, midnight. The world sleeps. The winds have slowed. The streets are quiet. The windows are dark. And yet, high above, the clouds still stir. This is the world of midnight storms, a quiet, delicate dance that unfolds while the earth rests. There's something singular about storms that form or persist at this hour. They are neither day's end nor morning's beginning. They exist between, in the stillest space the sky can offer. And it's in this space that the atmosphere often becomes finely balanced. By midnight, the surface is usually cool. The ground has exhaled its warmth. The boundary layer is stable, settled, and calm. But above that layer, things may still be moving. The low-level jet often peaks during this time, flowing a few thousand feet above the surface, carrying warm, moist air across the land. This air rides up over the cooler surface like a stream over ice, and in doing so, it can lift parcels of moisture into higher, unstable layers. This is where midnight storms are born, not from the surface, but from the elevated atmosphere. They drift into being like thoughts surfacing from sleep, quiet, persistent, alive. From the ground, you may see their presence only in flashes, lightning illuminating distant towers. You may hear thunder, not sharp, but rolling, echoing softly across the sleeping countryside. There may be no wind at all where you stand, no rain, just the flicker of cloud tops beyond the hills, a faint breath through the trees, the occasional hush of leaves turning over. Midnight storms tend to be organized. They form from systems that have matured, supercells that have decoupled from the surface, or MCSs gliding steadily eastward, guided by upper-level winds. There is no rush to them, no daytime chaos, only motion. And that motion is a kind of choreography, a balance between cooling and lifting, between outflow and inflow, between what has passed and what still lingers. Some storms at midnight last only a short while. Others continue until dawn. They may weaken, or they may grow stronger if the environment allows. But they do not shout, they whisper. Their lightning reveals shape and structure, arching across clouds like quiet brushstrokes. Their thunder is steady, rhythmic, almost hypnotic. You may sleep through it, or let it lull you deeper. It is not a storm that demands attention. It is a storm that reminds you that the sky is still awake, even when the world is not. So tonight, if you find yourself awake in the early hours and notice the flicker of light outside your window, know that you are witnessing something rare, a storm dancing softly across the highest stage. Let it pass like a wave over your thoughts. Let it move as you remain still, and let us now follow it deeper. Welcome back to Chapter 37 of The Sleepy Meteorologist. Tonight, we stay grounded, close to the earth, close to the rooftop, close to the sounds that help us rest. This is the quiet gift of late-night rainfall, a sound so simple, so steady, that it becomes something deeper, a rhythm for sleep. Not all rain is the same. Some arrives in bursts, with clatter and wind. Some races across the landscape in a rush of noise. But night rain, especially the kind that falls after midnight, tends to be gentler, slower, more deliberate. The storm has passed its peak. The atmosphere has settled. The air is cool and moist, and the rain begins to fall with a kind of peaceful persistence. You may hear it first on the roof, a soft pattering, like fingertips tapping on a drum. Not loud, not demanding, just present. Then on the windows, then on the trees, then on the world. This sound, soothing, repetitive, familiar, has been linked to rest for as long as people have listened. It masks sudden noise. It lowers the heart rate. It carries you into a deeper kind of quiet. And beyond sound, there is feeling. The rain brings coolness to the air. Humidity softens the breath. The breeze becomes fragrant, earthy, fresh, a little sweet. The world seems wrapped in a blanket of moisture and hush. But how does this rain arrive? Often, it's the trailing edge of a larger storm system. As convection weakens and the storm organizes into a broader shield, stratiform rain takes over, steady, layered, and widespread. These systems don't produce towering clouds or flashing lightning. They don't stir the air with gusts. They simply rain, slowly and with purpose. And the earth receives it. Soil drinks deeply. Leaves bend to catch droplets. Puddles gather softly in sidewalks and fields. The rhythm of falling water becomes the night's voice. For meteorologists, this kind of rain may appear as a wide, soft band on radar. No dramatic reds or purples, just green, calm, smooth. It tells a different story than the sharp echoes of daytime storms. It says, the atmosphere is cooling now. The clouds are thinning. The work is nearly done. And for you, lying in bed or resting in a chair, this rain brings not only moisture, but meaning. It reminds you that not all storms are loud, that sometimes the most important part of a storm is how it ends. It ends in nourishment. It ends in rhythm. It ends in rest. So tonight, if you hear the rain, let it hold you. Let it speak in repetition. Let it soften your thoughts and settle your breath. It's not just water, it's a lullaby. Now, as the rain continues to fall, we move into what comes next, the air it leaves behind. Welcome again to Chapter 38 of The Sleepy Meteorologist. Tonight, we explore what the storm leaves behind, not just puddles or wind-blown branches, but something you can feel with every breath. This is the gift of storm-washed air, a kind of clean slate, a freshness that rises softly by dawn. After a night of rain and cloud, when the storm has moved on, and the sky begins to open, the atmosphere feels different. It's subtle, but unmistakable. You may step outside and notice it, a coolness that isn't just temperature, a scent that isn't just moisture, a stillness that feels new. The science begins with purification. Rain doesn't just fall, it cleanses. As raindrops descend, they collect particles in the air, dust, pollen, smoke, pollutants. Each droplet acts like a sponge, gathering debris and carrying it to the ground. This process is called wet deposition, and it leaves the air cleaner, clearer, and more comfortable to breathe. But the experience is more than chemical. It's sensory. you may smell something sweet and earthy. That's petrichor, a fragrant compound released when rain touches dry soil. It rises from sidewalks, gardens, forests, and fields, blending with the scent of ozone left behind by lightning discharges. The result is a signature fragrance, the smell of fresh air after rain. Subtle, damp, charged, clean. This washed air is also more stable. The turbulence is gone. The temperature has equalized. The humidity has softened into a gentle mist. And the wind, it no longer races. It drifts, carrying the scent of the night's renewal across neighborhoods and hills. By dawn, the clouds may begin to break. Soft golden light filters through. Fog may hug the low ground, a final exhale from the storm. And through it all, the air remains still, but vibrant. Birds begin to stir. Leaves drip slowly, and every inhale feels just a little deeper. For meteorologists, this post-storm air is a sign of a system completing its cycle. The pressure may be rising again, the atmosphere rebalancing, the land restored. But for the sleeper, the dreamer, the early riser, it is a moment of clarity. It's the kind of air that feels like starting over, the kind that makes you pause and breathe. So tonight, or tomorrow morning, when the storm has passed and you open the door to a damp, glowing world, remember, this air has been washed by the sky itself. It carries the memory of thunder, the softness of dew, the rhythm of rain, and now it carries you into calm. Let's follow that freshness. Welcome back, friend, to chapter 39 of The Sleepy Meteorologist. Tonight, we ease into one of the softest places in weather. Not the height of the storm, not the rush of rain, but the silence that follows. That deep, wide quiet. That hush that feels like holding your breath after a sigh. It isn't just poetic, it's scientific, and it's beautiful. This is the science of silence after storms. When a storm passes, the first thing we often notice isn't the clearing sky, but the change in sound. Birds are still, trees no longer whisper, the thunder is gone, and even the wind has stopped moving. It's tempting to call it stillness, but it's more than that. It's a moment of atmospheric balance. Let's explore what's really happening. During a storm, the atmosphere is in motion. Air rises rapidly in updrafts. Rain falls hard through downdrafts. Thunder shakes the air. Lightning pulses. Winds surge outward from the storm's core, especially near the surface. All of this movement is the sky's way of releasing energy, balancing pressure, redistributing heat, and moving moisture. But once the storm has spent its strength, everything begins to resettle. The rising motion slows, rain tapers off, wind speeds decrease, and pressure begins to rise again. This increase in pressure is part of the story. Storms often form in low-pressure environments, places where the atmosphere is less dense, where air is encouraged to rise. But after the storm, cooler air sinks back toward the ground, and pressure begins to rise. The atmosphere compresses, becoming more stable. This makes it harder for new convection to form. The sky grows quiet because it wants to be. Wind, too, often calms after a storm. The gust fronts and outflows have passed. The boundaries that stirred the air have faded, and with fewer contrasts left to resolve, the air simply rests. Sound travels farther in this kind of stillness. You might hear a single drip of water from a leaf, the gentle sigh of a branch, your own breath, clearer than before. This is not an absence. This is equilibrium. Meteorologists sometimes call it a post-frontal calm. It's the part of the system where the energy has dissipated, and the atmosphere becomes stable, stratified, and still. But for those of us lying in bed, walking through a quiet street, or looking out a window, it's a moment of wonder, a chance to listen to the world without its usual motion. Some say animals return slowly in this silence. Others feel a kind of emotional stillness, a sense that something has ended but left a gift behind. And perhaps that gift is this: the reminder that every system wants to settle. Every burst of energy finds rest. Every storm is followed by a return to balance. So tonight, if the world feels unusually quiet, if the air is thick with calm, if the only sound is the hush between movements, that is the science of silence. It isn't empty. It is full with peace, with clarity, with renewal. The earth isn't sleeping, it's resting. And now, so can we. Let us move now to the final chapter, the gentle return of light. Welcome, dear listener, to chapter 40 of The Sleepy Meteorologist. We've travelled far together, through wind and rain, through lightning and lift, through cloud and calm, and now we arrive at the end, or rather, the beginning. This is dawn after the storm, not dramatic, not loud, but quietly profound. After a long night of storms or dreams or thought, morning begins in small ways. First, the blackness fades into blue, then gold begins to touch the sky, and finally, the world wakes. But when dawn follows a storm, it feels different. The air is washed, the earth is damp, the colours are deeper, as if everything has been rinsed clean. You may see dew sparkling on blades of grass, catching the first rays like scattered stars. You may hear birds, tentative at first, then joyful. You may smell petrichor, the soft perfume of rain on soil, still lingering in the cool air. And overhead, the clouds begin to part. What once loomed as towers of thunder has now thinned into streaks of cirrus or patches of fog. The storm is no longer present, only its memory remains. But it's not a heavy memory, it's not fear, it's closure. The storm came, it moved through, and now it is gone. For meteorologists, the aftermath of a storm is when the final data is gathered. Rainfall totals are measured, winds are logged, lightning counts finalized. Satellites show the retreating system sliding eastward, dissolving as it goes. But for the rest of us, the morning after is experienced more simply. It's a cool floor beneath bare feet, a sky washed with light, a world reborn in moisture and hush. Dawn after the storm is when clarity returns. To the sky, to the land, to the mind, and sometimes even to the soul. You might not remember when the storm ended. You might not have heard the last thunder or the final drop. But in this moment, you can feel its absence. And in that absence, a new presence. Sunlight, stillness, peace. This chapter is not about forecasting. It's about noticing. The way light touches a puddle. The way the clouds drift with no agenda. The way the day begins, not because it must, but because it can. So, as you rise, or rest, or remain tucked in a little longer, know that the storm, whatever form it took, has passed. And in its place is beginning. Not a dramatic return, but a gentle one. The kind that doesn't need to announce itself. The kind that simply is. Thank you for walking through this sky with me, through every chapter, every cloud, every hush and rumble and return. Now, with light gathering and the sky open again, you may begin your day, or drift a little deeper into sleep. The storm is memory. The earth is still. The air is clean, and you are home. Good night, or good morning. From the Sleepy Meteorologist. Rest well, and as we reach the end of our exploration, I hope this journey brought you calm, a sense of understanding, and maybe a little wonder. The sky has many stories, but tonight you've heard one told softly, just for you. The atmosphere is always moving, always shifting. But right now, you don't need to. You are safe. You are still. And the sky outside will take care of itself. If you'd like to support these gentle weather journeys, you're welcome to like or subscribe. Only if you feel like it. There's no pressure, just presence. Now, let your eyes grow heavy. Let your breath slow. There is nothing else to do. No clouds to chase. No storms to worry. Only the quiet, arriving like a breeze. The night is deep. The world is resting. And you can, too. Feel free to drift into sleep. Good night. Peaceful dreams. Calm skies to you, always. We'll meet again soon, under the weather. Until then, rest well.